We're going to now determine domain and range and whether something's a function from a set and also from an equation. Let's take a look at this first one. It's relatively straightforward. This is actually a discrete relation, meaning they're just individual little points, right? It's not continuous. So let's see, what is the domain of this thing? Well, my domain is just the x values. When I list my domain, if it's discrete, I'm not going to list the digits more than once. So if it appears twice, I'm just going to list it once. So let's go ahead and, oops, I'm going to put them in order, might as well. A -3, a 0, and a 1. Okay, so there's domain and range. Now, the next question is it a function or not? Well, if I do a little mapping here, I have a 2 and a 5, and I have a -3, 0, and 1. 2 maps to -3. 2 also maps to 0, and 5 maps to 1. Now, we talked about in the previous videos that if we have this situation that looks kind of like an open beak on a bird, then we don't have a function. So we're going to say this is not a function. Okay, not a function. Now you can look at some previous videos to see the reasoning behind that, but it does make sense that it is not a function. All right, let's take a look at this next one. All right, so we're going to need to determine the domain and range. Now, domain and range are asking this the domain is asking this question: what values of x would cause us to have real answers? Okay, so when we say real, we mean not imaginary, right? So we want just the real values. Well, we know that if this thing ended up being a negative, we would have a problem. We would not have a real answer. So the only thing that we can actually have is 0 or positive numbers, right? Showing up under the radical. The only thing we can have is 0 or positive. So instead of making a table on this one, I'm going to actually force the inside of the radical to be a 0 or a positive. Okay, I'm going to force it to be a 0 or a positive. Here we go. The way I force it is I actually cause it to be greater than or equal to 0. It's okay to be 0, so there's the equal, and it needs to be greater than. In other words, it needs to be 0 or it needs to be positive. So let's solve the problem. Solve the inequality now. Now this works really well for linear. If you get into quadratic, which is the next one, we're probably not going to do it this way, but we'll do it another way that's a relatively simple way. So here's what we know. We know that the values for x that would actually cause this inside here to be 0 or positive would have to be a third or bigger, a third or larger. So that's my domain. I can use a third, so I'm going to put a bracket there, and then I could go all the way up to infinity, and it would still be a value. It would still be real values, which means it's part of the domain. Okay. All right. Now let's take a look at the range. So there's the domain. Now the range means what values we're going to have for output. Now, here's where I'm going to actually go to a table. This will help a little bit just to kind of picture what's happening here. If I put in that 1/3, that boundary line, right? That's the cutoff between the non-real and the real. If I put in the 1/3, let's see what we get. We get 1/3 times 3, which is 1 minus 1. We get radical 0, which is 0. So if I put in a third, I'm going to output a 0. If I input anything bigger than that, larger than that, let's say I put in a 1. 3 times 1 is 3, minus 1. That's going to give me radical 2. Now, that's a real number, right? It's a decimal, but it's a real number, so it's positive, it's real. And let's see, how about a 2? That's going to give me radical 5, 3, 4. These are all going to be positive numbers, right? There's never a chance where we would actually put in a value of x and get a negative, right? It's impossible because it's the principal root. We're taking the positive root, positive or 0. So here's what I know then. I know that my range is not going to be anything but 0 and bigger, 0 and larger. That's my range. And I know that from right over here, making a table of values. There's no way I can create an output of a negative. Okay, so now, is it possible for me to create an open beak? We need to determine whether it's a function or not. If I put in a 1/3, am I ever going to get two different values for that? No, this is the principal root. That's implying that this is the positive, the non-negative, right? The non-negative version. And so, oops, and so there's no way that I could create an open beak. So this is a function. Okay? All right, last one. So the very first thing we need to make sure of is that the y is alone. So I'm going to go ahead and take away the x value to the other side, and I get y squared is equal to 9 minus x squared. Go ahead and take the square root. Now, because I'm taking the square root, as opposed to the last time where they already had the radical there, I'm taking the square root. I must put a plus or minus. Put a plus or minus. So there, I'm going to go ahead and highlight that so I don't forget there's a plus or minus there. Now, if I want to force, I'm going to force this right here to also be 0 or positive, right? Because we know that a negative under the radical is not going to be okay. All right, so we're looking for the domain, right? First of all, we know this thing is not a function. Can we just go ahead and say that? Because this right here, if I put in a particular x value, I'm going to have two y values, a positive version and a negative. So that's not a function. So we already know that. Not a function. But we still need to figure out what the domain and range are. All right, so let's take a look. I'm going to go ahead and separate this from the previous one there. Okay, so my domain and range, I'm looking for what x values would be okay, so I'm going to force this thing to be greater than or equal to 0. Now, an quadratic inequality is solved very differently than a linear, not like linear. And if you're not familiar with this way of solving, not familiar with solving a quadratic inequality, we can't go into it in this video, and so here's what we're going to do. We're going to act like this is an equals for just at the time being. We're just going to say, okay, that's an equals, and we're going to go ahead and solve it this way. So we have 9 equal to x squared, right? I want to get the x squared positive, and I've got x is plus or minus 3. So there's something about a plus or minus 3, and here's how we're going to finish this up. There's something about a plus and a minus 3 that's key for the domain. Let's take a look. There's 0 right there, right? If I put in a negative 3 into this, if I put in a negative 3, here we go. Y is equal to plus or minus 9 minus negative 3. Then that's going to be a 9, and that's going to be 0, and then the square root is 0. So if I put in a negative 3, I'm going to get out a 0. So here we go. We got our little table going here. Negative 3, I'm going to come out with a 0. So negative 3 seems to be okay to use. Let's put in a negative 4. Negative 4. If I put in a negative 4, I'm going to have 9 minus 16. And that's going to be a negative under there, and that's not okay. That's not okay. This down here is not okay. That part of the number line is not going to be a viable value for x. Well, what about 0? If I put in a 0, I'm just checking this situation here. If I put in a 0, if I put in a 0 for the thing, then I'm going to have the 9 minus 0, which means I'm going to have square root of 9, which is 3. Now remember, it's plus or minus 3. So if I put in a 0, I'm going to have a 3, but I'm also going to have a negative 3. And that's why we get this conclusion that it's not a function. So, but 0 is fine, right? I create an answer that is in the real world. What about a positive 3? Let's check that. If I put a positive 3 in, I square it, I'm going to get a 0. So I put a positive 3 in, I get a 0. I don't have plus or minus because there's not a negative or positive 0. All right, what about a 4? If I put in a 4, I'm going to have the 9 minus the 16 again, which is negative. That means that is not okay. So these right here really are messed up. Those are messed up. So I can conclude that my domain for this one has to be sandwiched between negative 3 and 3. The domain is sandwiched between -3 and 3. Okay, so let's look over here at the table, right over here at the table, and let's take a look at what the range would have to be then. I know that I can't ever get an output other than, I know I can't put in anything less than -3 or greater than 3. I know I can't put input, but what can I get in the output side? Well, I can get a 0, I can get a 3, and I can get a -3. I can get some decimals in between. In other words, my range is going to also be -3 to 3. There's no way I'm going to be able to get, just if we tried really hard to put in some values to get something greater than 3 in the output of it, there's no way. If I put in a 0, the biggest I can get is 3. If I put in the biggest x, I'm going to get a 0. So my boundaries are also -3 and 3 for the range. Okay, so we've answered the question that it is not a function, and there's the domain and range. I hope this is helpful. Thanks for watching.